All right, we have another situation. A type of bacteria doesn't double, but it triples every 1 minute. What is the equation of growth? So again, we start with our petri dish full of fluid here, and this guy's going to split. What is he going to do? He's going to triple every minute. Going to be a minute later, there's going to be 3 of them, and they're going to go on like that. So I start at time 0. Again, here's the timeline. I start with one of the little bacteria, and then I'm going to have 3 of them, okay, and then I'm going to have 9 of them, right? They're going to triple, and then I'm going to have 27, and 3 sevens are 21, 3 is 71.
81.
Like 81, sorry. There we go, I forgot to carry that, etc. They're going to go like that, 1, 3, 9, 27, 81, and they're going to grow like that, grow pretty quickly too. So what is the equation of growth? That's what we want to know. What's changed here? Well, they're not doubling anymore. Okay, we used to have n, remember n of t equals 2 to the t. They're not doubling anymore, so what's happening? Well, usually when I ask this question at this point with my students, they're getting pretty savvy, and somebody will say 3 to the t. And I'll say, all right, well, maybe it is 3 to the t. Let's give it a shot. So I'll put 3 to the t there, and I'll say, well, when the time is 0, and 3 to the 0 is 1, I do get one little critter, and that's what I got, one bacterium. If I put 1 in, I get 3. Oh, that's good. And if I put 2 in, I get 9. If I put 3 in, I get 27. And it becomes apparent that this is the right equation. So this number tells you about doubling, tripling, quadrupling, quintupling. In fact, suppose you had 5 times 0.75 the number every minute. And then you would put 5.75 here. And that tells you that kind of growth. Covers that kind of situation. So we'll go over here and we'll sum it all up, shall we? We'll move over here and we'll get a good picture of this thing. You might have to move it over, I don't know, but see if you can get all of this in here. And here's our general equation. I'm going to make this look a little better. The number that you have in time t equals n naught, which we call, that's the number we start with. The number you start with is n naught. How many do you start with? Do you start with 10,000? Do you start with 3? Do you start with 1? Whatever it is, you put it there. The A tells you whether it doubles, triples, quadruples, quintuples. You know, like if it's 6 times as many every 10 minutes or something, you put a 6 there, that kind of thing. Whatever it does. Usually you run into double, triple, and that kind of thing. But it could be any number. All right. The H tells you how long it takes to double, triple, quadruple, quintuple, and all that. So if it quintuples, you know, every 7 minutes, it would be quintuple would be 4, right? T over 5. Sorry. Quadruples is 4, right? Quadruples. Let's say it quadruples every 5 minutes. Let's say that, and then you put a 4 there. T over 5. See, it's good. If I didn't have my student here, I wouldn't know what I was doing. So anyway, that's the generalized formula. Okay. So let's ask the question. We're going to go down here. I kind of squeezed this problem in right here. A population of 250 rats in the math building triples every 1.3 years. What is the equation of growth? Well, the number at time t, let's see if I can get it right here. The number, if you can get it over here, the number at time t equals, I don't know if I'm going to be able to get that in there. Let's see. I start with 250 rats, right? And it triples, so that's, let me get a little bit more room. I'll move this, that's all. Move this out of the way. 250 times 3, it triples, right? And how often does it triple? It triples every 1.3 years. 1.3 years. And that's my equation of growth. Now, if I needed to know how many rats am I going to have in the math building in 5 years, I just put a 5 in there. And if I wanted to know when will the population of rats in the math building be 500,000, I simply put 500,000 here, 500,000, and I use exponential. I'll have an exponential equation. I solve for t, and I'll find out how long it takes to have 500,000.